I'd like to now look at a work problem. The definition of work is the dot product of the force and the distance. Okay, let's look at the example down below. This example says find the work done by a force of 3 pounds acting in the direction of 30 degrees to the horizontal and moving an object 4 foot from the point 0, 0 to the point 4, 0. The first thing here is to draw a picture. All right, we're taking an object, we're wanting to move it from the point 0, 0 to the point 4, 0. The force is acting at a 30-degree angle to the horizon. Okay, and I'm going to create kind of a triangle here. We've got right triangle. I'm going to call this at the bottom the distance. Up here at the top, we'll call this the force. The distance on the bottom as a vector could be represented by 4I, okay, because I'm moving a scalar multiple of 4I. All right. On here, I could also, and I do want to note this for something that we do a little bit later on, we can also say that this is 4I plus 0j if we need both components of that distance vector. Okay, the first thing we want to do is we want to write our force in terms of I and j. Now this is something that we haven't covered yet, but we're going to do it now. Okay, the force F, it turns out in terms of I and j, can be written as 3. Okay, we were saying that we were applying 3 pounds of force. Okay, and this is multiplied by the cosine of whatever angle that you're given times I plus the sine of whatever angle you've been given times j. Okay, so in this particular case, this will be 3 times cosine of 30 degrees times I plus 3 times sine of 30 degrees times j. Okay, I hadn't really gone into why this is the case. I'm just going to take this as fact for this particular moment. I'm not going to use this a whole lot, so just trust me here on the formula for my force. On here, since I know the angle 30 degrees and I know what the cosine of 30 and the sine of 30 is, I'm going to go ahead and compute those two things. Cosine of 30 degrees is the square root of 3 over 2. And then over here, sine of 30 degrees is 1/2. And so I'm able to get these constant multiples of I and j. So I've got 3 square roots of 3 over 2I plus 3/2 j. And that is my force vector in terms of I and j. Okay, now the reason I needed to find that is I needed the horizontal and vertical components off of that particular vector. Okay, now what I need to do is I need to find the dot product of this vector f and then the vector d. So the work done is the dot product of the vector f with the vector d. Okay, remember how this works is it's the horizontal component off of f times the horizontal component off of d plus the vertical component off of f times the vertical component off of d. Alright, the horizontal component off of f was 3 square roots of 3 over 2. Horizontal component, if we'll scroll up above, where I have written in blue, the horizontal component we can see is 4. Okay, plus vertical component on f is 3/2. And then scrolling up above, we see vertical component on d is 0. So that second part will 0 out. Okay, here multiplying, I put the 4 over 1, so this will end up being 12 square roots of 3 over 2, and then that simplifies down to 6 square roots of 3. And then if we want to estimate that, decimal representation is 10.392330485. Okay, now the unit for work is foot-pounds, and so on here it's approximately 10 foot-pounds of work being done to move this object. This concludes this example of a work problem.